Hi everyone, and thanks for joining us. We're going to take a look at arrangements of objects in a line. If I'm arranging 3 objects in a line, how many ways can I do it? If I'm arranging 7 objects in a line, how many ways can we do it? Let's take a look, try an example, and see if we can figure it out together. In order to begin, when I refer to arrangements in a line or arrangements in a row, what exactly do I mean? Let's look at these 4 cards here, the Jack, Queen, King, and Ace. The important question is, how many ways can these 4 cards be lined up in a straight line? Well, this is one arrangement, Jack, Queen, King, and Ace. Another arrangement might be this, Jack, Queen, Ace, and King. Another arrangement might be King, Queen, Ace, and Jack. So how many total possible arrangements in a line would there be? Let's take a look. So let's make example 1 out of that question with the 4 cards. In how many ways can 4 cards be arranged in a row? But in mathematics, we actually have a fancier word than the word arrange, and that word is permutate. So I'm going to change the question to, in how many ways can 4 cards be permutated in a row? Let's think about this card by card. Let's say we're going to arrange our first card, the Jack. In how many ways can the Jack choose to go into the row? At the moment, the Jack is the only card, so the Jack only has one choice. One permutation for the first card. So far the number of ways is simply 1. The second card comes along, the Queen. Since the Jack is already there, how many choices does the Queen have and where to stand in the row? The Queen could stand here or here. So the Queen has 2 choices. Let's say she chooses this side. So we are permutating the Queen and the Jack. In mathematics, whenever we say the word and, it usually implies multiplication. So now we multiply by 2. The number of permutations for the Jack lining up in a row, and the number of permutations for the Queen in the row. Remember, she had 2 choices. Now along comes the King. How many choices does the King have in where to stand in a row, considering that the Queen and the Jack are already there? The King may stand here, or in the middle, or here. The King has 3 choices. Let's say the King chooses the middle. So we are considering the King as well, and the King's permutations are 3, then we multiply by 3 as well. And now along comes the Ace. How many choices does the Ace have as to where to stand in the row? The Ace has 4 choices. The Ace could stand here, or here, or here, or here. 4 permutations when we add the Ace. Let's say the Ace stands over here. So adding the Ace's permutations of 4 to our calculation, we get a multiplication of 4 as well. And this is what we get. 4 times 3 times 2 times 1, which is 24. But before we write 24 as the answer, this pattern here of numbers multiplying and going down by 1 actually has a specific notation. It is called the factorial notation. And 4 times 3 times 2 times 1 is an example of this, and this can be written as factorial 4. 4 with an exclamation mark following it means 4 times 3 times 2 times 1. Okay, and the final answer, of course, is 24 ways. So in summing up for this question, there are 4 factorial ways to permutate 4 objects in a row. Let's take a deeper look into the factorial notation here and how we actually summarize it. So if I have 6 factorial, that means 6 times 5 times 4 all the way down to 1. Just like that. And if you multiplied all these numbers out, you will get 720. Similarly, if you had 9 factorial, that would be 9 times 8 times 7. All the way down to 1. Just like that. This one's going to be very big. You may need a calculator to do this. The answer, 362,880. If we had to write factorial as a formula for every possible general case, we would say factorial n, which means n times, and one number less than n would be n minus 1, and one number less than that would be n minus 2. And that would go on all the way down to 3 times 2 times 1, where it would get to eventually. But this only actually works for positive integers, okay, or positive whole numbers. So let's just add a little note. For integers n greater than or equal to 1. No, that's not correct. It's actually n is greater than or equal to 0, not 1. Really? Oh, that's strange, but we can't arrange 0 objects in a row, can we? Well, you're right, you'd think it wouldn't make sense, but when you enter factorial 0 into a calculator with a factorial button, it gives a valid output. It doesn't give an error message. Really? The calculator says factorial 0 is okay? It can be done? Okay. I guess we need to change it. For integers n greater than or equal to 0. So at the moment, I'm actually unable to explain why this is, but I will in the very near future. Factorial 0, and your calculator will agree with me on this, is actually equal to 1. So we now have the formula to calculate how many arrangements there are of objects in a row. But for this question, let's actually write out the different arrangements as well and check that the factorial formula works. Writing out different permutations and arrangements is a skill that you'll need for this area of mathematics. For the first part, A, we have one letter. How many permutations are there for one letter? Easy, just one, A itself. That's it, only one way to do it. And the factorial tells us that the number of permutations is factorial 1, which is 1. Agrees. Let's now look at B. How many permutations are there for the two letters AB? Well, you've got A on the left, B on the right, and then B on the left, A on the right. 2 permutations are possible. Does our factorial formula give us the same answer? 2 objects in a row, factorial 2, which is 2. 1, 2. That agrees. What about 3 objects in a row? A, B, C. Getting a little trickier now. To do this, I'm actually going to use our answer for B to assist me. So to list out the permutations, let's do all the ones that begin with A first. A, and then how many ways can I arrange B and C? 2 objects in a row, there would be factorial 2 or 2 arrangements for that. A, B, C, and A, C, B. A, and then we worry about the arrangements of the 2 letters following it. So this would be factorial 2 ways. Now let's try the permutation starting with B. There will be 2 of these as well, B, AC, and B, CA. So B, and then permutate the 2 letters following it, okay, which is just like our answer for B. 2 factorial for that as well. And the final 2, the permutations starting with C. C, AB, and C, BA. C, and then the permutations of the 2 letters following it, which would be factorial 2. And this actually gives us another way to see the formula. The answer should be factorial 3. How can we get factorial 3 from this mess? Add them together. Factorial 2 plus factorial 2 plus factorial 2 is 3 lots of factorial 2, which is actually equivalent to factorial 3. Agreed. 3 objects in a row can be permutated 3 factorial ways. 6. 1, 2, 3, 4, 5, 6. Final answer of 6. Now let's look at D. Getting really tricky now. 4 objects in a row. We know the answer is going to be factorial 4, but let's list them out and see if we can derive factorial 4. So first of all, let's do the permutations of A as the first letter. A, and then how many ways can we permutate the other 3 letters? That would be factorial 3, which is 6. So they're going to be 6 permutations beginning with A. A, B, C, D. A, B, D, C. Now let's put C second. A, C, B, D. A, C, D, B. And now let's put D second. A, D, B, C. And A, D, C, B. So there were 6 of those, or we just thought about the arrangements for the final 3 letters, which is 3 factorial. Now let's do the arrangements for B as the first letter. Hopefully you've got the hang of this now. Try and work ahead of me if you can. And there are 6 of those as well, which comes from 3 factorial. The letter B first, followed by all the permutations of the following 3 letters. Let's finish this off. Try and finish it before I do.
Come on everyone, go quickly. You can do it. Feel free to hit pause if you have to. You can finish it before him. He's pretty slow, you know. Oops, watch out. I think he's finished. He may have cheated.
And as you can see, we get 6 permutations for each beginning letter. A, B, C, and D. 3 factorial, and there are 4 lots of them. 3 factorial added together 4 times will give us 4 times 3 factorial, which is simply 4 factorial, which gives us 24. And as we can see here, this agrees. We have 6 by 4 permutations, giving us a total of 24. E, 5 objects in a row. Ugh. Do I have to write them out?
No, you don't have to write them all out. I wouldn't want you to exert yourself now.
Oh, good. But let's just imagine what would happen anyway. The first group, if we put A first, there would be factorial 4 ways of writing permutations with A as the first letter. That's how that would look. And then factorial 4 permutations with B as the first letter. And so on all the way down to the case where E is the first letter. Factorial 4 added together 5 times will give us 5 factorial. So if you actually wrote them all out, there would be 120 different permutations of 5 letters. So there we have it. That was a pretty long process, but it just confirms that factorial n is the number of ways that we can permutate n objects in a row. All that writing out permutations has left me feeling pretty hungry. I feel like eating an apple, a hot dog, and a muffin. But which order should I eat them in? This is simply a question that is ordering 3 objects in a row, just lining them up on the table before I eat them. How many ways can I line up 3 objects? The answer for this question is 3 factorial, which gives us 6 ways. For example, one permutation would be eating the apple first, and then the hot dog, and then the muffin. Another permutation would be eating the hot dog first, and then the muffin, and then the apple. In total, there would be 6 ways that can happen. Let's take a look at another example. Example 4. How many ways can we line up 8 people in a row to take a photo? This is an arrangement question, so this is about permutations. We are simply arranging 8 objects in a straight line. How many ways can this be done? Simple. Factorial 8. We're going to need the number. I'll just get my calculator.
Stop. No, don't you dare.
Why, what's wrong?
You don't need a calculator to do that. It's not that big. Write it out and multiply. It's good practice. It's like doing weights for your brain.
Weights for the brain? Really?
Yes, really, weights for your brain. Do you have a problem with that?
Okay, well I better get started. What's the easiest way to do this? Okay, 5 times 2 is 10. I might bring that to the front. And then 7 times 8 is 56. And then 4 times 3 is 12. And 12 times 6 is 72. Okay, so I've just got to do 56 times 72. I got it. 4,032, right?
That's right. See, it wasn't so bad, was it?
Okay, so 10 times 4,032 is 40,320 ways to arrange 8 people in a row to take a photo. Whew, that's a lot of permutations. Would you like some weights for your brain? We hope so, because it's now your turn. Please try examples 5, 6, and 7. In example 5, how many ways can 7 people sit down to watch a movie in a single row? In example 6, how many ways can 10 cars be lined up in a single line to drive down a road?
You may use a calculator for example 6. It's okay.
And for example 7, how many ways can the letters P, Q, R, and S be arranged in a row? For part B, it's your turn to write out the permutations.
And the total number of permutations you write out should be the same as your answer for part A.
Please feel free to leave your answers in the comments, and thank you for watching.